Good day, everyone. Today, we are going to discuss experiment number 2, which is the determination of unit weight of aggregates. This experiment focuses on determining the density and unit weight of fine aggregates, or sand, and coarse aggregates, or gravel. These properties are important in concrete mix design because they help ensure the strength, stability, and durability of concrete structures. Through this activity, we also learn the proper techniques and procedures used in engineering practice for measuring aggregate properties accurately. The objectives of this experiment are to determine the density and unit weight of fine and coarse aggregates, to understand the importance of density and unit weight in concrete-related experiments, and to apply proper engineering techniques in determining these properties for practical construction applications. Aggregates are one of the main components of concrete. Their density and unit weight affect the overall quality and performance of concrete mixtures. For fine aggregates or sand, the volume is determined using the water displacement method. This method measures how much water is displaced when the sand sample is submerged. For coarse aggregates or gravel, the material is placed in a metal container and compacted using a tamping rod. The mass and volume of the gravel are then used to calculate density and unit weight. Determining these values is important because irregular particle arrangement, excess moisture, or poor compaction can affect concrete performance and durability. Materials and equipment. The materials and equipment used in this experiment are gravel, sand, potable water, weighing scale, container, graduated cylinder, paper, metal container, and tamping rod. Procedure for fine aggregates. First, 3 closed cylindrical paper containers were prepared with dimensions of 1 inch in diameter and 2 inches in height. Each container was filled with sand. Second, the mass of each cylinder filled with sand was measured using a weighing scale. Third, a graduated cylinder was filled with 600 milliliters of water. 1 sand cylinder was submerged and the final water volume was recorded. The difference between the initial and final volume represented the volume of the sand sample. This process was repeated for all samples. Fourth, the density was computed using the formula density equals to mass over volume. Lastly, the average density was obtained and the unit weight was calculated using gamma equals mass times 9.8066 over volume. Procedure for coarse aggregates. For coarse aggregates, the metal container was first filled 1/3 full with gravel. The gravel layer was compacted using 25 strokes of the tamping rod without striking the bottom of the container. Next, the container was filled up to 2/3 full and compacted again. After that, the container was filled overflowing and rodded once more. The surface was then leveled using the tamping rod. The mass of the gravel was measured for 3 trials. The density was computed using density equals mass over volume. Finally, the average density and unit weight were calculated using gamma equals m times 9.8066 over v. The volume used in the calculations was based on the volume of the metal container. In conclusion, the experiment successfully demonstrated the determination of density and unit weight of fine and coarse aggregates using proper laboratory procedures. The water displacement method provided an accurate way of measuring the volume of fine aggregates, while the rodding and leveling method ensured consistent measurement for coarse aggregates. The computed densities and unit weights are essential in construction material estimation and concrete mix design. Overall, this experiment highlighted the importance of accurate measurements, proper compaction, and correct testing procedures in civil engineering applications. Thank you for watching.